Okay, this is going to be a quick review of relations and functions. Okay, and typically you start talking about these in fifth or sixth grade, but they show up in Algebra 2, college algebra classes just as a review. So they may show up like on an SAT, PSAT test, or ACT. Okay, relations can be shown as a grouping of ordered pairs, a table of values, a graph, or a mapping. And here's an example. Here's a set of ordered pairs. Here's a table of XY values. Here is a graph. Notice I haven't connected the dots. These are just discrete values, so they haven't been connected. And then here's a mapping. All of these show a relationship of a relation. These are relations. In order for it to be a function, not all relations are functions, although all functions are made up of relations. So this is how you tell if a relation is a function. It has to pass the vertical line test. So notice in these examples, I have, here's my linear equation, here's my quadratic equation, here's my ellipse. We're going to take this red vertical line and we're just going to run it across the whole graph. And notice, no matter where I were to take that vertical line, I could do it here, I could do it here, I could do it here. It only touches that green line in one location. Let's look at the quadratic. Touches one location, touches one location, touches one location. Let's look at the ellipse. It touches, doesn't matter where we run through there. So this equation is not a function, but a linear y equals mx plus b. The only exception to linear equation is when you have a vertical line, say x is equal to 5. I'll call that 5 right there. Vertical lines are not functional because look at, you put another vertical line on top of that vertical line and they touch it infinitely times. So vertical lines are not functional, but all other linear equations are functions. All quadratic equations are functions. So in general, polynomials are functions. All right, vertical lines are not functions, okay? Then, yep, here's another example. Y equals mx plus b, function. Horizontal line, y is equal to a number, function. A negative mx plus b, function. X is equal to a number, not a function. So linear functions have a constant rate of change. Nonlinear. So think about this as straight lines versus curved lines. So if there's a curved line, it is not linear. Straight lines are, and the word line is right in linear function. Nonlinear, so quadratic, exponential, logarithmic, cubic, those are all examples of nonlinear. All right, I think that's it for relation and fun. Oh, want to point out, you can also tell when things are not a function. This is really important. Can't believe I almost forgot this. You look at a table or you look at the x values. If there are any repeating, if any of the x values are the same, not a function. So in this case, all of the x values are different, so this is a function. But if you had a table that looked like this, -2, 5, 1, 8, 7, -7, -2, 4, 6, -12. As you'll notice, there are repeating x values, so this is not a function. The other way to look at it is look at a graph. So when I did the ellipse down here, notice, let's say I just graphed a graph that looked like this. Notice right here, if we took a vertical line, there, it passes all the rest of them, but because it does not pass this vertical line test, this would be an example of not a function. Okay, that's it. Good luck.